So are you finally ready to write some unit tests? Ready? Now let's go into test accum.py. If you don't have the file, you want to create that file. And I'm just gonna put this side by side just to quickly import some of the things that I need. There is a way to just import everything by just doing the asterisk. For example, you can do something like from TaskQuant. Look at the path here. It says TaskQuant score accum.py. So you can say TaskQuant.score, and you can say .accum import everything. Just do it like that. But typically, I don't really like doing this. What I like to do is to just be more explicit. So I'm just gonna say create multiple lines of them, and let me just see what I need from here. All right. So I obviously have the underscore functions. So let me go ahead and do that first. Just gonna copy this, extract task, and then I have the underscore task to dig, and I have the create full date. So underscore create full date, and then I have field rolling date. So let me just say field rolling date, and then I have create combine table. So let me say create combine table, create table auto. So let's go ahead and do create table auto. And we have score accum. So let's do score accum. So these are all the things we want to import from accum.py. And to do a unit test, to start you doing unit tests, you can just import unit tests. And this is kind of a built-in Python module for testing. So once you import unit tests, you want to make sure that at the bottom of this, you have the if name underscore main you want to just say unit test.main. Just a simple routine. All unit tests begin with some sort of structure that looks like this. And now we're going to just have our class, and we're just going to say class and give it a, we call this accum. So let's just make it clear to ourselves and just call it class test accum, and within it, it would inherit from unit test.taskCase. And this is where we start to write our tests. So get yourself set up, import unit test, if name equals to main, unit test.main, import all the functions that you want to be testing, and then class test accum. You can create another file called test underscore utils, and you can test all the other things in utils. All the things that you have in utils, you can test them. And once you've done that, you can feel free to close out this one. You don't need that anymore. So now you have more space to work with this. And class test accum, in here, we're going to test each of these functions. And we want to make sure that if a function fails, we can isolate that. And oh, okay, the problem is in task to dig. Oh, the problem is in field rolling date, right? So we can isolate that. And that's kind of the whole point of unit tests. That's the beauty of it, is that if something breaks, you know exactly where to look for, and not trying to look at the massive function that we wrote in the first place and not have a clue where within the function is it failing. Okay, so let's write the first test case. This is how we do it. We want to start a name, and we want to start a name with test. So test underscore, and then whatever you want to name next. So for example, if I want to test for an invalid path warning, I want to say invalid path warning self, and this is what I'm going to do here. And what I expect to do is I want to test that there is a warning if path seems wrong. Why do I say seems wrong? Because it may be the fact that it may be the case that it's actually wrong, or it may just be the case that there is nothing in the path. So that is the correct path, but there is no task in it. So we're just passing in a warning. So in this case here, when you write a test, you want to make sure that there is at least a warning coming out if you pass in a path that looks suspiciously empty. Okay, so let's see, how do we do this? Now we want to create a invalid path, so you can just say invalid path. Let's say task path to be more explicit, and we say test, and we say test data. Right, now we say assert warn. So we can say with self assert warns, and within assert, there are multiple options you can pick from, but what we're really looking for is warns. So it says warns with a warning. And here we can try and do something in here that leads to this warning. So let me show you what accum is doing, just to remind you. So I'm going to put accum maybe to the right of this. What's really happening is this code right here. So we want to check and say, hey, if the task looks empty, well, it could be that is the right path. It could be that you have actually specified the correct path, except there is no task in there, or that you haven't completed any task. So in that case here, there's a warning. I want to make sure that this runs. So to do that, I'm going to put an invalid task path, and then what I'm going to do is I'm just going to call the scoreboard function, because it's going to enter from the scoreboard and it's going to error out here. So you can just call a function right away, and you can say scoreboard, and within scoreboard you want to pass the task path. Here it says this is the name of the parameter, is called task path, so we want to put task path, or you can just use positional argument, that's also fine, but let's just be more explicit now. This is one way of doing it. Another way of doing that is to just move this into extract task and just test for extract task all together with the invalid path as well. We're not going to do that. We're just going to keep it simple like this. This is good enough. This is a really good practice, so we're just going to keep it that way. And just to make sure that all of this still works, so the first thing we need to do is to just get down into the terminal again, and we want to just run pytest, so Python, and we want to say Unittest -m Unittest, press enter, and it says it ran one task, and the one task is passed. So when you see a passing task, you get a dot. If you see a fail, you see a capital F. So one dot means one passing task. So congratulations, you just wrote your first task and your task has passed. So let's go ahead now and try and write a task where this should actually not error out. So in your case, you may create a sample task box, and we may do that later. We may create a sample task box, but for now, I'm just going to use my task box, the actual one that I'm using. And if I load it in, I should see that there are multiple tasks already and not just 0. Okay, so I can do a task. Now I'm going to say this is a valid path. So earlier on I said task invalid path warning. I can now say task valid path. And you follow the same ideas up here. Gonna just take the, maybe just even copy that and move this down. But now just gonna have this as valid task path, or just call it task path without the valid. And this is where you want to specify that. So again, like I said, you can feel free to go and create a fake one just to test it out, just for testing purposes. We're probably gonna do that, but not in this video. I just want to keep things simple here. I'm just gonna say this is where my tasks are stored. So if I do this, then I can then check whether or not there are enough tasks in it, because if the task amount is 0, then I know this is wrong, right? So I can take a look at the code that I have here, and I can say go ahead and perform the extract task, and then I can check for the length of completed. Okay, so perform the extract task job and then check for the length of completed, and it should be greater than 0. I don't know how many tasks I have, maybe 5, maybe 10, maybe 11, but it should be a non-zero amount. So let's go ahead and say extract task. And what do I want to do here? I want to say task path equals to task path. And from here, and you don't really need that, you can just use positional argument like I said. You can do this, but I'm just going to keep it this way now and just say completed is that, and I'm just want to check for the length of completed. So the length of completed, I expect this value to be greater than 0, because this is an actual directory, and within it, I have actually completed some task. So I'm going to just say self assert greater than 0. So self assert greater than 0, I don't have assert greater than 0, so I'm just say assert greater, and I'm going to say length of completed needs to be above 0. So let me run this test now, and Python -m, that's module, run the module unit test, enter, run 2 tests, and both tests pass. Great. Now let's see, we have the invalid path, we have the test valid path. What else do we have? So we have task to dig, we haven't really had that yet, and you see that the ones that we have a slightly more vibrant color, a shinier color, and the ones that we haven't really used is still in there. So we want to test all of this. Yes, so let's go ahead now and do the next one, task to dig. So create some space at the bottom, define task to dig self, and we can again copy the same one here, move this down at the bottom, and this is a kind of a good place to then create a routine, and we probably talk about that, a fixture that would just automatically load for that. But in this case, we always start from task path, and then we just read the path in and do something with it. Now it's up to you what you want to do. You can either just do extract task again, just like the one up above, or you can just use score accum because it does the same thing. It reads that in and load all of that stuff. But really what you want to do is to really test that the task to dig function is actually working. Okay, so when you have task to dig, whatever task that is in there, you should find that they should be the same as when they were converted to the dictionary. So if you want to, you can just copy completed, paste it in here, and within this, you can just have your, these are all your tasks. I would just call them tasks from now on instead of completed, but they are the same ideas here. So if you want to name this task as well, you can change this to task. You want to change this to task as well, just to be more concise. Instead of completed, we have task. And once we have abstracted all of that, let's find the first task and the last task, and let's take a look at the date of those things, right? So let's have the date. Let's say task, the first task is gonna be 0. We want the completion date of the task, and we're gonna say n. That's the first one. And then we want to take the first one, this one, and we want to find the difference between that and the last task, the date of the last task. And the whole point of doing this is that we can now check and see task to dig is doing the right thing by actually taking task to dig here, and we can say task to dig return what? Let's see. 3 things, right? The aggregate start date dig, the start date, and the end date. So we have 3 things. We only need the first. So let's go ahead and say ag date dig, and we don't need the next, the 2 others. So we're just gonna put underscore underscore, and what it's gonna do is it's gonna take the task. So you're just gonna copy this, put this in here. And then what we're going to do is to just quickly do an assertion here to say that, hey, do you have enough keys in that? Remember the same technique that I showed you, that you can actually do a lang on the dictionary. On the dictionary, if x is a dictionary, you can say lang of x, and x is a dictionary. It gives you how many keys are there. And so what we can do is we can just say self assert equal of what? Of, we need to have enough keys in here. So let's say lang of this with the number of days in between these two. So let's go ahead and just say this is days apart. And then from days apart, we want to say that this is the same as this. So you just copy that, put this in here. Now I feel like I have a feeling that this is probably something that I'm going to be using a lot, so I may want to just create another function to do that. But for now, let me just go ahead and do this. And it says, oops, this is not the same, because this is a date time, this is 14, they're not the same. When you take a date and you minus another date, what happens is that it returns a time delta. So what you want is to have the time delta be converted to a days. So you want to say this dot days, and you want to run that again. And if you change that to, this is not 0 and 1, this is actually going to be -1, because you want the last date and the first date, because then they'll be task apart. You want to take the final date, which is the most recent date, the date closest to now, and the beginning of the date. So this is the last task that you just completed. This is why it's at the end of the list, right? -1, right? Because in the task itself, we already sort them by date. You see that sorted in here. So if we run this correctly now, we should see, okay, it's saying that now it's correct, but we forgot to convert that into an absolute number. So we want to set the days apart, take all of this, and we just want to put an absolute. So now it should work. We save this. Okay, now I run all the tasks and it works. So this is kind of how you test it, is that you're saying that find the most recent task, which is why it's at the end of the list, because we sort it chronologically, and then take the first one. If let's say this is 17th of January, then this is 11th of January, then 17 minus 11, that's 6, and then it will give you a -6, right? So what you want to do is to just absolute turn that into positive number, and you want to check whether that you have the same number of keys in the dictionary. Because if this function is doing its job, you should have exactly the same number of dictionary, because this is what the function is doing. So notice the pattern here of just isolating that one function and just test for that on its own, right? And so this is what it's doing. So if we scroll all the way back up, we see that the create task to dig is done. Now we have create full date. So we need to test for that. We need to test that there is no breaking days. If we were to pass in a start date, 15th of January, and then 19th of January, there is no breaking dates. That means if there is a skip, there is a day where we skip, we didn't do any task, it needs to still create that anyway and pass in a value of 0. So let's go ahead and do that now. So let's say def task create full date self, and a lot of this stuff are going to be similar. So just going to copy that, put them in here. And from here, I'm just going to say copy the same thing as well. But instead, now I need the start date and the end date. So I have the start date and I have the end date. This is so we can create the full date, because in the full date, if you look at the one that you wrote, let's scroll to that area, create full date, it needs a start date and an end date. So you do need a start date, end date, and a dictionary, date dictionary. So we do need to pass in the 3 items here. If we just copy this blindly up here, we're not gonna have that, right? So let's go ahead and do this. And we accidentally delete that earlier, so let's not delete that. Let's copy this, paste this in here, move this down, because we accidentally cut where we really just want to copy. And then we have the start date, end date. And within this start date and end date, what do we want to do is to just create the full date. And the full date is basically just this function, the create full date function. So you can even just copy that from right, take this, pass it in here. So we have the start date, end date passing right in there. So this is what it's doing now, full date. Now, how do you know that full date is doing what it's supposed to be doing? What is full date supposed to be doing? Well, it needs to create a non-breaking. It should pad the values with 0 if there is a missing date. Yes. So let's go ahead and say, what is our expected number of keys for the dictionary? So let's maybe think about this for a bit, and then we can say how many keys should we expect in the full date? Okay, that's the same idea as this, right? Is to just find how many days should we fill. So this, how many keys do we expect if the full date is doing its job, right? So we look at the start date and we look at the end date, and we say, well, maybe we can just find a way to just count the number of days between start date and end date. And if it's a non-breaking sequence, then that should just be the number of keys in there. That means full date is doing what it's supposed to be doing. Yes. So what do we do here is very similar to what we have up here. So I thought maybe this is the right time to just create a helper function, and this helper function could just be called diff of date. So we can say something like diff of date, and diff of date is just going to be date 1, d1, d2. Actually, just call it date 1, date 2, not to be lazy. And we're just going to return what? Return exactly what we have here. So take all of this, copy that, cut that, and paste it here. So we have return apps, and we're not going to do this. Instead, we're going to say date 1 minus date 2, date 1 minus date 2 days. And we have diff date, so let's copy that. And now in days apart, we're just gonna have to use what we just created up there. So we're gonna say diff date, and then we have task, take the last one, take n. Then the second parameter is task 0 n. So this is equivalent to what we have earlier, except now it's just its own helper function, because we can then use reuse the same logic, so you don't have to repeat yourself. You want to try to not repeat yourself. And in the same case here, we can just say diff date now, and we can just pass end date, and we can pass in the start date. Whoops. And this is kind of what it's doing. So for example, I have 14th of January, 14 Jan, and all the way till, let's say, 18 Jan. Now, how many days should I have? How many keys should I have here? I should have 18 minus 14, that's 4. But in the dictionary, I want a plus 1, because 14, 15, 16, 17, 18, I want a plus 1. If I only have 4, then I'm still 1 short, right? So the number of keys should actually be 18 minus 14 plus 1. So there should be 5, because then it will be 14, 15, 16, 17, 18. So we want to add 1 here. So that's the expected number of keys, and we can go ahead and say self assert equal, and what do we have? We say assert equal the length of the full date, which is just the number of keys on the dictionary. If it's doing its job correctly, we should have that. So meaning if we pass in a broken mailbox and if we pass in a task if we pass in a task file directory where there are maybe 14, 15, and then 17, 18, it will still fill that up. So that's the difference between them, the end date and the start date, and then plus 1. So it should make sure that there is no broken dates in here, and that any value, if you need to pad it with 0, pad it with 0. So that's what it's doing. Let's go ahead now, save all of this, just run our test again. Ran 4 tests, all pass. So 1, 2, 3, 4, all of them pass. And if you kind of get what I'm doing here now, I encourage you to pause the video and to just go ahead and complete the remaining 3 of them. Alright, so I already have the 1, 2, 3, 4 done for you. I just want you to go ahead and complete the 3 of them. If you want to, just pause the video, try and write out the rest of the tests if you can. And if you can't, it's okay, we're still learning. So we come back to this and try to resume from there. So let's take a look at how many tasks do we have left now. We have task create full date. That's right here. We have the field rolling date. We haven't really done this yet, right? So what does field rolling date actually do? Now, if you're going back into the accum.py and let's search for rolling date. So this is what it's doing. It says it perform a rolling sum using full date. So if you pass it a series of date, it should be able to sum up each one of them and perform a rolling sum, right? So if you pass in something like 1, 4, 5, then it should, field rolling date should be able to take this and it would then have this as 1, 5, 10. So 1 plus 4, 5, 1 plus, and then 5 plus 5, that's 10, or 1 plus 4 plus 5 is 10. So this gives us field rolling date. How do we reflect that in our test? To do that, let's go ahead and create some mock data so that we can use the mock data and pass it down into our function, right? So let's go and write a helper function here, and we're just gonna have it called def. We're gonna just say create mock full date. So we're not actually gonna have the real full date. We're just gonna mock it, and then we're gonna use the mock and pass that in here. And if the function should work, if the field rolling date should work, then it should work regardless of whether this is a mock data or not. If this works as intended, then the test should still pass, whether or not we are actually using the real full date. So let's go ahead now and just create some sort of, we want to create a dictionary structure where there is some date here, date 1, and then we want to have something like 10, and then we want to have date 2, and this is a sequence, a series of date time, so we have like, let's say 20, and now you should go and perform the sum, and 10 plus 20 will be 30, so you should be doing that, right? So let's go ahead and just create some of that, and just to mimic that. We don't really need the date to be exactly what we have in here, but we just need to have enough of a structure. So enough talking, let's write some code. Today, I'm gonna just say date.today. Now, do I have date.today? Do I have date? I don't have date. So let me just go ahead and say from datetime, import date. And good practice is to just move all of the Python standard libraries, move those import at the beginning, at the top. Your own internal imports, bring it down below. Now that we have date.today, this is gonna be what we have here. This is gonna be what we pass into the dictionary. So let's go ahead and create a dictionary. We can create a dictionary up here. We can say full date. And now let's just do something really simple. Let's just say pass the date and increment the date by day of 1. And from there, so this is date, let's say this is gonna be, just to show you what I mean by that. So I'm gonna just say from date time, import date. And if I show you date today, that's gonna be today's date, right? And what I'm gonna do is I'm just gonna increment this by 1 day. So I'm gonna use a time delta. I'm gonna use time delta, and I know that already. So let me just import that. So from here, I can also say from date time import time delta. What I would do is I would just increment that, and I would have something like a dictionary. And in the dictionary, the first key would be today's date, then the second key would be an increment of 1, then an increment of 1, and then increment of 1. And for each of the value, it's just some random numbers. It could be a random numbers, it could just be a 0 to 10, right? So I'm gonna just write the code real quick now for I in range, and here we could say from range 0 to 10, and what do we do? And we can also just simplify this to 10 if we want to. If you want to just be more explicit, you can leave it there. And I'm going to just use the same update function that we've seen before. This is a trick that we've used before. This is kind of a way of saying that if the value already exists, update the value. If not, create the value. Okay, so what do we want in here? Now we want the key to be today's date. And we want the value to just be this, which is the range of, so the first value is going to be 0, and then 1, 2, 3, 4, 5, the last value is going to be 9. Okay, so let's go ahead and just say 1. Then once this is done, you want to step the today by 1. So you want to say increment the today. Want to increment that by time delta days of 1. This is the same as saying that today equals to today plus time delta. It's the same thing, right? So we're just going to stick to this one. Remember, we want to make sure that we return something from here so that we can actually use it. If we're just doing this, we're not actually going to get anything back, right? So we want to make sure we return. What do we want to return? We want to return this dictionary that we just created called full date. So we want to put that in there, back in there. So we want to put that back in there, return full date. And now we have the create mock full date. What we can do is to just go back to the task there, mock the full date, and then test for the function. So let's go down and write our code. We want to test the field rolling date, correct? So what we need to do is to just copy this, and in here we just do the same thing. We say define test, and hopefully paste the whole thing. Take a self. This is where we use the mock. So because it returned a value called full date, just to keep it consistent, I'm just going to call full date just to not confuse myself too much. And this is how you then use the mock. From here, what we need to do is to test and see whether or not the rolling date function, the field rolling date function, is working as intended. This is supposed to perform a rolling sum using full date. So you want to see if 0 up to 9, so 0 plus 1 plus 2 all the way to 9, would that give us the value, right? That is one way of checking whether or not this function is working as intended. So let's go ahead and just call the function and see if we can get it to be the same as what we expected. So we're going to pass in full date here. This is where we set up the assertion. So if you want to pause the video right now and do a real quick check and see whether or not the value would be the same as what you expected, you can do so. But if you have a dictionary, and let's call this dictionary X, if you have something like A equals to 1, B 2, C 3, what you can do is you can just take the values of X just like this, and you can sum them. So you can sum like this, and it will just perform a sum. So we could just check and see this is what the expected value. So this is the expected value if we were to sum across the values of our dictionary. So with that, let's just go ahead and transfer what we have in the terminal into our code. And what we're going to do is to just set up an expected, and we say expected equals to sum of, if we were to take all the values in here, so sum full date dot values. So what this is going to do is saying that, okay, if I take all of the value, then I will say that the last value in rolling date, the last value, if it performed correctly, then it should be the same as the sum of all of them. What I'm essentially doing here is to check for inequality and saying that if this is working as intended, the last value of rolling date, that should be the cumulative value of all of the values above, and that should just be the sum of the entire thing. So we could just go ahead and just say self.assert equal. And what we do here is we set the rolling date, take all of that, and put them into a list maybe, right? Put them into a list and say rolling date dot values. Okay, so this is all of the values, but we only want the final one. So we want to say take the list, which is here, take the final value of that, and what? And compare to the expected value. Would they be the same? Okay, if you need to pause a second to sort of think about this and reason about it, do so. But here essentially is saying that if this is performed as expected, then you would have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And by the time you get 9 to 10, it would have really summed up all the values above it. So that would just be the same as just to sum all the values in the full date. So if all of these pass, then your test should pass. And then when you perform it on your own data, on your actual data, it should still work. But if you want to be slightly more careful and you want to just do another round of check, you can also do that. For example, what I can do is I can also do is assert equal, and I can check for the second last value. And the second last value, so I'm just going to copy what I have here. So I'm just going to say this, and this is going to copy all of this. And I'm going to say, what about the second last value? So second last value, instead of the last value, -1, I'm going to have -2. So negative indexing is in Python, what it means is to just take from the last. So you just take from a last, all right? So -1 is the last one, -2 is the second last. And then we just have to change the way we write our sum. So we won't be doing all of the sum anymore, but what we can do is we can do a sum values, and then we can do something like subset for up to the last value. So this is gonna perform, in the case of this, it's just gonna perform all the way up to the last one. So -1 is the last one. So you're saying that take all of that all the way up to the last one. So if that works, then this should also works, right? So we say x, and we say all the way up to the last one. So if we're doing this, we expect the value to be 1 plus 2. The answer should be 3. So it shouldn't include the last one anymore, right? Let's run that. What does it say? It says dig values object is not subscriptable. So one solution, one workaround is to just put this into a list so that it can be subscriptable. So let's wrap this into a list. Okay, now it's subscriptable. So all we need to do is to reflect that as well in our code base. So list like that. And this is really the power of actually having an IDE where you can have a terminal open up and really quickly iterate and make sure that values work, make sure that your code work before you actually commit them into your script. And so here we see that, okay, if we just do the x.values and then try and subscript that, Python is going to complain and say, hey, this is not a list, this is not anything that can be subscriptable. Then we say, oh, what if we convert this into a list? What if we change this to a list? Would that work? And Python said, okay, sure. So now that's what we have. So the second last value would be the same as if we would just take 1 plus 2, which means omitting the last value. All right, so let's save that. So we have task field, rolling date now. And now we have one more item gone. So the next one here on the list is create combined table. So let's copy that, go all the way down. And let's say def, task, and we have create combined table. We have an extra underscore there. Put a self in here. And let's think about this. What does this do? To actually understand what this does, let's again go back to create combined table in our actual code and make sure we know what it's doing. And it seems like our code here is a very simplistic, very basic function of just combining two lists into one. So this shouldn't be a lot of trouble here, but let's just complete it for the sake of completion. So I'm just gonna say take full date and rolling date, just combine them two. So we need the full date, we need the rolling date. And I know this because I have this open up and I can see full date and rolling date here, right? So I see full date, I see rolling date. So I know that I need these two of them. And then I'll just replace this with the pass. And so I have full date, I have rolling date. This is how I know I can pass this into the arguments, pass it in as arguments later. And then all I need to do is to just say combine because this will just operate on this two. Right, so let's go ahead now and just say create combined table, and we pass in the full date. That's the first parameter. The second one is rolling date. Let's do that, and let's just give it a name as well. We call it combine L. And because this is so simple that really this you don't even really need a test for this because it's really doing, you know, a append operation. So essentially you're testing whether Python's append is working or not. But like I said, just for completion's sake, I guess there are a few things you can do here. One is to just maybe quickly assert an equal and see whether or not the length are going to be the same. So self assert equal. And let's say if the length of this is the same as the length of this. So essentially if this function should work as expected, then this assertion should check out, it should pass, right? Well, another way to be more precise and actually a much better test than this is to think about what would be combine L. What would be the value of that? What do you expect combine L to be, right? So let's go ahead and say expected value, just like what we did there, and think about what we have. So full date. So in full date, we know in full date, this is where we created full date. And we know that when we're doing this combine L, it's going to take 4 keys in them and then append, the first thing is the string of the key. So what would happen if I take the string of today's? So let me say datetime.today, date.today. That would just be this. So I know if I set up the last parameter, if I set up this, if I check the last argument, so I want to say that expected last argument, for example, this is the last. So I know if I check for the last value of combine L, that would just add 9 days to this. So I can go ahead and say time delta days equals to 9. And that would be this date. So the expected value in terms of this is the last value of combine L. The first element in this list should be something of this effect. So let me just go ahead and do that real quick. Grab all of this, copy this, and I'm gonna say this is the first element. So it says, okay, iterate through full date, which is here. Take the string of the key of the full date. So I know that's gonna be the date. And then I just have to wrap everything in string just to confirm to this. And then the next one is what? It says full date key, rolling date key. So the value of full date and the value of rolling date. Now the last value, remember if you go up here, this is going from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I take the last value, I expect this to be 9 because that's just gonna make sense, right? From 0 all the way to 9 because this is for I in range all the way, and then the last value of that will be 9. So I know that the second value should also be 9. So let me just go ahead and say the second value should also be 9 because that's full date to key. What about rolling date key? Well, rolling date key is just a sum of 9 plus 8 plus 7 plus 6 plus 5 all the way down to 1. And if you figure that out already from the earlier exercises that you did here, then you know that this is going to be 45. Okay, so this is 9 plus 8 plus 7 all the way to plus 1. And that would give you a 45. So you know this is what you expected. Now, how do you check whether that confirms with what you get? Okay, so this is the expected value of the last element of combine L. So we can go ahead and perform an equality check again, but this is a list. So we need to use some specialized function, and this is called assert list equal. So assert list equal is going to say whether or not these two lists are the same. And the first one is just going to be expected, and the second is just going to be combine L, the last value. So I hope you're starting to see a kind of pattern here is that we always set up what we expected the value to be, and then we check and see whether or not that turns out to be correct, right? So, or whether or not the function performs as intended, because if it performs as intended, then it should conform to our expectation. So our expectation is that if we were to look at the last value of combine L, this is what we expect to see. And so this is what I'm doing here to assert that and see if that passed or not. So I have task create combine table, and we can move on. And now we have the last one, which is create table auto. So before we do that, let's just go ahead, quit out this, and let's do a quick Python unit test just to see how many of our tests passed so far. So it said failed, ran 6 tests, failed error 1. And where do we fail? It says line 64. So let's scroll to that, which is here. And it says here that dig values object is not subscriptable. So it looks like we did not put in the right thing in here. We need this to actually be here. So then the list would operate on this, and then that would be -1. So let's see now that our test is working. Now there is another issue, line 67. So apparently the same issue. So let's go ahead and do that as well. Now let's run this. Okay, now all of that passed. So now we have the last task. Now the last task is create table auto. I've seen people who said, well, this is really just printing a bunch of things. There's really nothing much to test for this. So let's take a look at the create table auto. So what I like to do usually when I try to write tests is I like to refer back to the actual code and decide, or what kind of a strategy do I want to take here. So create table auto, let's search for that, create table auto. That's here. And it's actually just a bunch of print statement. If it gets into create table, it's still a bunch of print statements because you can go back, you can go into create table and you can refer to that code there, and you see that it's just a bunch of print statement. There is no real value in here that we can use to sort of build our test, to construct our test. But luckily for us, there is a way to sort of test for the existence of this print statement. And that is why I want to introduce you to the next thing. And this is from Unittest.mock. So you can import patch just like that. If you don't want to do that, you can just specify the full path unittest.mock.patch. You can also do that, but I just want to save myself some typing later on. I'm just going to say patch. Now let's take a look at create table auto. Let's copy that, go all the way down, and here we're going to write our tests. Self. Honestly, the beginning of this test is still going to be the same thing. We want to test the create table. We want to make sure that we at least have the combined list in order to fit this into the function. So why don't we just go ahead, copy all of this, put it in here, Control K, Control V, Control K deletes the line, Control V paste it in. Now we have combined L. Now let's take a look at what we need. So we have the combine L here, that's good. Now what about the second item? Combine L headers. We don't have the headers. So let's go ahead and create the headers. And we can just make it really simple. Just have it as date. Then we have a total. And we have rolling. I'm not even sure if that's what I call my tables actually. It's actually date score cumulative. If you want to, you can change them. Date score cumulative. And now we just need to check for the print statements here. So thankfully we've loaded in our patch, and we're going to use the mock to sort of mock the print behavior. So with that, let's go ahead and just write our with patch. And in patch itself, this is where you specify what is it that you're trying to patch. So in here, we're trying to say built-ins, because that's actually a built-ins. From there is something called print. So within Python, there is the built-ins, and then within the built-ins, there is the print. So if we do a built-ins, whoops, we have to activate Python. Say built-ins. When we have the module, we say built-ins.print. That gives you the print function. So if you say import built-ins, that's the module of built-ins. That's something that when you install Python, it comes with it. And that is why you can use print statement, and that's why you can do all of this fancy stuff. So within it, we just call import built-ins, and if from built-ins, we just have to take a look at the print function. And now we said with patch built-ins.print, and just create the context manager, and we say mock print. Okay, what do we want to do here? We want to test for this create table auto. So let's do that, create table auto. And let's take a look at create table auto again, because I know there's a couple of things we need to pass to it. So there is the 1 arguments, 2 arguments, 3, 4, 5. Okay, so that's at least 5 of them, right? So let's go ahead and see if we can fill in all of them. So the first one is combine L, we have that. So let's copy that, let's put this in. Then the next one is headers. Do we have that? Yes, we do. Copy that, put it in here. And then verbosity. And why does it need verbosity? Oh, because if it's verbose, we need to print out extra information here. So let's just say false for now. We don't really care for that right now. And then it needs a completed length, because if it's true, it needs to pass. If verbosity is true, it needs to also put some values in here. Now for us, we're not gonna actually see the effect of that, so we can put in any values in here. Doesn't really matter. I'm just gonna put 9. And then finally, let's take a look at the last one. It says what? Date length. Date length also doesn't matter, because again, it won't be printed out. At least not these 2 print statements. We won't actually be looking at them, because we're just gonna set this verbosity to be false. So let's just actually put a 9 in here. And if you want to, you can maybe write a better test that actually accounts for all of this, but I'm not gonna do that now because I feel like the video is a little bit too long now. So let's take a look. What else do we have? 1, 2, 3, 4, 5. Okay, that's fine. And what we'll be doing is we're gonna call this create table auto, and then we're gonna actually catch for the print statement that was there, and we're gonna see whether or not that was printed out. All right. And because there is currently 2 kind of scenarios. One is the tabulate scenario. One is the create table scenario. And if I currently run this task and I have tabulate installed on my environment, then I know this is gonna evaluate to true. But what if somebody else who is trying to perform the same task, then that guy is gonna go into this one. So it's not a very deterministic behavior. And to account for that, I'm just gonna slightly modify the create table auto function, and I'm gonna change 1 or 2 things. The first thing I'm gonna do is I'm gonna change here, and I'm gonna add one last thing. And here I'm just gonna say tick and say if I want a plain table, and I'm gonna set that default to be false. But if the default is true, then it should only print the plain table, which is here, which is to say to just ignore what's happening in tabulate. So I can say if plain is false and tabulate in this. So if plain is false, which is the default value by the way, so plain is defaulted to false. If plain is false and tabulate is in the environment, then go ahead and use the tabulate feature. But if tabulate is not loaded or plain is true, then do the other one. And from here, I think this is also when I can move, if I want to, I can move the import from here. See, the problem here is that if I have an environment and I actually have tabulate installed, then I will never come into this line because I will never have an import error. So I'm not actually going to be able to load this line, and that line is going to fail. So I'm going to get an error message later. So I need to sort of take this and go all the way into the create table. So auto, let's search that up, auto table. And I'm going to say print this. Okay. And the reason why this is saying that if my environment do have tabulate, then there is no way I would import this, because the accept will not even, I will not even enter this block of accept, right? So maybe what I should do instead is to just import that here so that it doesn't complain later on and say, hey, I don't know what create table is because I don't see it. All right, so I'm gonna just do that. I say that, okay, if the plain is true, then just go, if plain is true or tablet is not in there, then go ahead and do the rest. And then I don't have to change any other things in my code because I have a default value there. So even if the value is not in, passed in during the method call, during the function call, it shouldn't really matter. So I'm just gonna save this file, and when I come back here, I will now have to pass in a true because I actually want to force the behavior. So this could be create table plain, for example. And then you can write another task if that's something you want to practice. You can just create another task and actually test for the fancy one. But typically, as a rule of thumb, is that anyone else library, you don't have to write tasks for them because they have their own tasks done on that library, on that level. So we don't actually want to test any third-party dependencies. So we're only going to test our own create table. Does that make sense? So anyone else, if you're using third-party, if you're using NumPy or Pandas or Matplotlib, you don't want to write tasks to test Matplotlib. You don't want to write tasks to test Pandas or NumPy. What you want to do is to write tasks to test code that you've written yourself. So in this case here, I just want to test auto, and that should go without saying that I don't really care how it looks like in Tabulate. I'm just going to assume Tabulate has the right task in place to make sure that my code will work. And then for create table, this is what I want to be testing. So now I have combined headers. Let me show you all of that again because there's been a handful of work we've done here. So combine L, that's here. Combine L headers, that's here. Verbosity, we're going to set as 4. So these two doesn't matter. Just put some values in here. And then plain, I'm going to set that to be true. That way, I guarantee that this code is going to hit. And when I'm going to come into this code, what am I going to do with the create table is to execute this. And when I execute this, what should happen? Let me look at create table. This should happen. So in here, when I write my task, I want to make sure that I have some expected value, and the expected value, if the create table function work as intended, should match my expectations. So we can go ahead now and just do a import sys, and I'll show you how to actually test for that print. Okay, and there is a trick here where you can do something like print, and within sys there is something called stirred out. So stirred out stands for standard out. And every time you print something onto the console, that's actually standard out, right? So here I'm saying print stirred out, and I can do something like tick stirred out, right? And that would, then I can write whatever it comes out from here. Another way we can do this is we can just ignore all of this, and we can just say tick mock underscore print, which is from this. This is the context manager. So within the context manager, there is something we can access here. Why? Because we already used the patch. So we can say find the call args list. I want to take the first element of that first, and I'm gonna wrap all of this in a string. I wrap all of this in a string so I can later write the expected. Okay, and I'm doing the first one because I want to first make sure that the headers are being printed out. So this is my headers. I want to make sure that the headers are being printed out correctly according to what I specify in create table. So let's go ahead now. Let's open up some space because I know this is going to be a long line of code. And expected header. If you look at if you look at the create table in here, you will see that this is how our row string will look like. So I'm going to try and write the whole thing out and then maybe explain to you line by line. Or if we can use the terminal to just quickly test things out. So let me just go ahead and take the headers, copy that. Now I have headers. Then what I can do is I can write something fancy like backslash to escape that T, and I can say join, and here I can put X, Y, Z. I can put X, Y, and it says it takes exactly one argument. So we actually need to put all of them into a list like this. And this is kind of the same thing here. We can actually take all of this and we can put in our headers here. And so it should give us this date score cumulative. But we also began our header with some extra tab before we go into these actual headers. So if you look at the headers itself, there is some extra tab, and then you multiply them. So I say take this and multiply by 3. So take this, this, this. There is 3 of that, and then we put all of the headers in there. But before they even begin, there is already a tab in front of it. So this is a tab in front of it, and there's a tab behind it as well. So what I need to do is actually, this is still not complete, but I can copy that. That's a good start. I want to take this, and I want to go into my expected header. I want to put this in here. Then I want to add the extra front and back. All right. So let's go ahead and add the extra front and back. I know this is quite a handful now, but let's do it here. And then we're going to add the same thing. Gonna say, whoops, whoops, like this. All right. We can delete the other one here just to keep one. This is kind of what I expected header to be. It may look very intimidating in first glance, but it's really just to try to create this, and we're saying that, okay, backscape, escape the T, and then finally do the join. This is kind of doing what we have here, and then this is the expected header. Now, how do we make sure that the assertion is written now that we have this patch, now that we have this mock? So we use mock print, which is the context manager name. So the name of the context manager we have here, up here we have mock print. So this is all indented properly, and mock print. All right. So mock print assert called with, and now we need to create this string here that would be exactly what the output of mock print would show us. So we need to have an extra call bracket, and in here, this is where we're gonna pass the expected header in. Okay, so I know this looks a little bit too complicated now, but pause the video and slow down if you're trying to keep up with what we're doing here. And I'm gonna just put expected header, and that would just at least go through the first line. I said, okay, is that you know, do I actually print this out? So here you're actually essentially mocking the print, and what I mean by that, let me deactivate that, and let me just go ahead and do a TQ. Okay, so I need to work on that and clear the screen. And now let me go and do a TQ. We see that there is the header up here. This is the fancy one. If we don't have tabulate installed, then it's gonna have a plain one. But we want to print for the first row. We want to make sure that the first row actually looks like this. Okay, so let's go ahead and now clear the screen again. Now what we're gonna do is just gonna perform the unit test, run that, and all of that works. So we do have the call, and that call turns out to be exactly what we have in here. If you look at what we have in create table, it's going to actually run this print how many times? 10 times, because it says for row in table, print. So if you want to, you can go ahead and say, what about the last row? Can I take a look at the last row? And you can do that. So all you need to do is to change this line of code. Let's copy that and let's paste that down at the bottom, and let's print that, say 10. Now if I run the Python unit test module again, let's see what happens. Or let's actually instead not have the index and just print out all of that, and let's see what's happening there. So if we do an import print, this is still gonna work because we don't have, there's nothing that's printed out because it doesn't fill. So let's try and fill it. Okay, so if you, this is what we expected, and this is what is actually being called. And if you look at that, this is a long list going from the first, then the second, and the third, and it all goes like call and then the square bracket, which is why we actually try to replicate that. So we have the call and then the bracket, then we have the date score. So this is the first one, and this is what we were testing, and that's why it passed. But then if you look at the last one, this is what we have here. So can we try and see if we can test for the last row of our table and see whether that would be exactly this, right? So if you want a bit of challenge, you can do that. If not, if you think that that's too much, feel free to just ignore the last part of this exercises. But I'm just gonna go ahead and take this, and I'm gonna pass this back as 0 just to make sure that it all still works. Alright, so it says here that it failed. Let's clear the screen, rerun it again. Okay, that's because we mess up the bracket here. Just take that, put it in like this. So now we're actually taking the format and passing it here. Let's go ahead now and do it. And now it works. Now it works. Alright, so we have the mock print assert called with. So if you want to, an extra challenge here is to how do you then do it for the last one instead. So the last one, if you scroll all the way up, you see that the last one is actually going to be the last row of the table. So how would the last row of the table look like? If you want to, I'm going to work it out for you. We're going to say 10. And you may be tempted to try a -1, but it won't work. So we just kind of use a 10 here. And then what we're going to do is we're going to say expected last row. The logic is not very different from what we have up here. So we're going to just have the same. We're going to say take that T. And now we're going to join something. Okay. So what do we want to join here? What we want to join is we want to join the, at least in each of the row, we have the extra tab. Then we put in the table content, and then we have an extra tab at the end as well, just like the headers. Okay, so I know that there is going to be an extra tab up here. Then there's going to be the value, the value in the row string, and then within the rows. And the reason I know that is because if you look at the row, we're actually unpacking them and putting them in here, right? We're saying that take the row string and format them this way. So what we can do here, we just have to create a list. Within the list, the first one is going to be nothing. That's just going to be a tab. And then from here, I'm going to say string, and I'm going to take exactly what I have, which is up here. So I'm going to take the string of date today. So that is what's going to appear. And if this is getting a little bit hairy and you're like, oh, well, where do you get this from? Well, just remember that when we run TQ, this is the value we're getting. And I'm looking at the last row, so I want to add 9 days to it, because if I forget about this, then I'm only testing for the second row. So after the header, that's the first row, and then the second row would be today. So I don't want to test today, I want to test the last row. So last row, I'm going to have to add 9 to it. So just like what we did above. And from here, I'm going to, because I know that there is still an extra space, extra tab after that, I'm just going to put this. So every time you see an extra nothing in here, that's just going to feed the T. So this is going to give us, this is going to be fed in here. And this is also going to be fed in here. So this is going to give us the structure here. All right. Then what happened after we done that? We have this value to feed, right? And what is this value going to be? Well, we know that this is just going to be a 0 to 9. So this is very simple. This is just a 9. So a 9, because when we create that mock, we started off 0 all the way to the end. The last row is what? 9. And then the last column, this column, what would this column be? What would this column be? Now this column would just be the sum, the rolling sum of all of them, and we already have the value. We worked that out already as 45. So what we need to do is to just put a 9 and then just put a 45. When you try to join a string like that, Python is going to complain because it says, hey, 9 is not even a string. What are you trying to do? So let's just go ahead and make it a string now. So it doesn't complain at us. And we have that. Now, do we have a last tab? I think we do, because we still need to add this. We still need to add the last \t there, which is from here. So let's go ahead and do that as well. So that is the expected last row. And with all of this, you can now copy that line, get below, and then we can just say expected header, change that to expected last row. So the rest is all the same, but we're saying that, okay, if you look at the last one, then this is how it should look like, or this is how you expect it to look like. I can save that, and we can now run our unit test. Now it runs all the tests, and all of them pass. So we have all 7 tests, all of them pass. And if you manage to follow this far, well done. Now you have a well-tested Python package, and we're ready to now publish this to PyPI. So what we'll do is we increment our Python package version, and then we push the new version to PyPI. And when other people do a pip install, they're going to be able to get our latest version with the well-formatted code now. We take the big monolithic Python function and we break them down into all the different helper functions, and then we write tests for each one of them. So now that we have that, let's go ahead and do the publishing. So the first thing we're going to do is to go into init.py. So let's do a init.py, that's TaskQuant, going to do that, and we're going to increment that by 1 version. What we're going to do next is we're going to take a look at the source control and make sure that init.py, that's incremented, okay. And then there's the accum.py, that's all our reformatted code. Then there is the task accum, that's what we just created with all of the changes we written in there. So with all of this done, let's go ahead now and create our build. So to do our build, we're just going to follow what we've learned before. We're just going to say Python setup.py. We're going to create 2, source distribution and the build. So let's do that. and now it's saying TaskQuant 0.04. That's being created. If you look at the build folder now, so there's that, and the distribution folder now, so you see that there's all the way up to 0.04. So that's with all the changes that we just incorporated in here. Then the next step you want to do is to just use Twine to upload that onto your PyPI. So want to do Python pm and Twine upload skip existing, and in here it says find whatever you can find within the dist directory, but skip existing if they've already been uploaded. So if 0.01 has already been uploaded, then don't attempt to redo that. And I'm going to just enter. It says my username. I'm going to put my username in here. Enter my password. I'm going to enter my password. And it's now uploading. You can see TaskQuant 0.004. It says skipping TaskQuant 0.01 because it appears to exist. Same for 0.02, same for 0.03. Finally, it says view at pypi.org project TaskQuant 0.04. So let's copy this and let's open up our browser and paste that in. And there you go. We have a TaskQuant 0.04. And if we look at the README, it's still all there. And this is the latest version. It says released 1 minute ago. So what we can do now is we can either do a pip uninstall TaskQuant and then do a pip install TaskQuant again, or you can just do a pip install -- upgrade TaskQuant. And this is what it's going to say is that try to install TaskQuant. If you already have that, find the latest version, upgrade that. Okay, so let's do that. And it says, okay, it's done. So it's still really, really fast. If you look at the distribution, this is the folder. And if you take a look at this in your Finder or in your Windows, you'll see that this is still below 8 KB. So this is still pretty cool. Really, really lightweight. With all of the new additions, with all the reformatting, restructuring, we're still at 7.5 KB. So that's still really, really lightweight. Okay, that's all we have today. So before we go, just gonna have to do a quick git push, git add. Gonna check all of this into GitHub so that you can find all of this. And we have to say this is refactoring and test. And we're gonna push them up to GitHub. If you want to take a look at the code, you want to have this open up side by side, you want to compare this while you write your own tasks, go ahead, take it from GitHub, fork it from GitHub, and try and complete the task on your own before you actually refer to the reference. But in any case, I hope you have a good day. I'll see you in the next video.